Hello everybody and welcome to the first lesson of the Roll-a-Ball project for the Blender game engine. And in this lesson we will prepare our scene, prepare our project and make a basic preparation of everything, objects and such for another game creation. So this is just a new blend file. If you're using the default settings, just delete everything in your scene so we can start with clear sheet. And first of all, save this somewhere. So file, save as, and make a new directory. This will be your project. Everything that you will ever use in this game or any other game, put it in one directory. So if I make here Roll-a-Ball 2, whatever, the name isn't that important, but if I would use some textures or sounds, external scripts, external blend files, everything will be here. So not somewhere in computer or external hard disk. Everything have to be here because later when you would want to port this game somewhere or put it on different place, or the links for the files will be broken, and it's really hard in big project to find why the object is pink or purple, because it's missing the texture, but where the hell is the texture? So keep everything in one file as one project. So this will be Roll-a-Ball like tutorial, for example. This example will be very basic and easy, so we will not use any assets, textures and linked blend files. We will just have one blend file with internal stuff. But still, good practice, keep everything in new directory and one directory. So save as blend file, and we will make game. So first thing you want to do is change the render engine to Blender game, and then some general settings. So for example, scene, this will be our main scene. You probably never change the name of your scene because for animation, modeling and anything you really don't have to. But in the game engine you often works with many scenes for different levels, for overlay scenes, for backgrounds, for whatever, and you need to name them because you want to address them somehow, and best way is by its name. So this will be main scene, why not? And the display settings set to not display, where it is, shading, GLSL. If you are making game for any kind of computer, use always GLSL. You really don't save any computing power or very little by making it only multi-texture, and multi-texture on the other hand is the only shading that works for Android or phone platforms, and we will not make anything for it. We will do just game for PC, for Linux, Windows, Mac. It should all work nicely in GLSL. But this is shading of our view, not the setting of the game. The setting of the game is in the render options. So here we set our final resolution, for example 1024 by 720. It's classic 720p, but 4 2 times 3. Anti-aliasing is your desire. It can slow pretty much your frame rate, but it's something that you want to try before you set some high or low values. If it won't affect your frame rate at all, go as high as you want. But keep in mind that you are not the only one that will play your game, so it's good either to have the setting in your game that player can set the anti-aliasing, or keep it low for better portability to different platforms, different computers. And here in shading, here has to be the GLSL. If here is multi-texture, it doesn't matter what we set up in viewport, we need GLSL here. And it gives us option to what we want render actually. And we will not use nodes, we will not use ramps or any extra textures like normal maps, bump maps and other stuff in this tutorial. And every time you want, turn off anything that it's not necessary for your current project. Maybe when I will make some later projects, I will show you what each of it does, mainly the nodes for some advanced shaders. And system, we can keep it, we can keep pretty much anything else for now. And set the world, because this is the world where our game will exist, so it has to work somehow. And I am doing this tutorial according to the tutorial for Roll-a-Ball game in Unity game engine. The link is in the description for these tutorials. So I will set even the world same as in Unity they have it, and they like the world have bluish color, no mist, physics always bullet engine. I believe there is no else, so none on bullet. Gravity, this is set to real world gravity, and we can skip for now the physics settings. We can tweak it when we start to tweak physics of objects to rigid bodies and such things. So this is pretty much all the general settings. So I will save it with Ctrl S, and this layout of windows is good for modeling, sculpting and such, but not really for making the levels and game. So I will tweak the setting. It's up to your preferences really, but I like the setting that I have the camera view, so the actual view how the game looks, the working view where I'm making the game, and the helping window, which can be anything that I'm currently needing. And most of the time I'm needing just Python console to try some lines of script, or just counting like 300 divided by 12, so I don't need to go anywhere for calculator or whatever. And here the settings of anything in Blender, so just this what it is, properties and outliner. And well, in game development you actually will use outliner, and a lot, so don't hide it anywhere, and keep it in mind that it's here. One thing for our visualization of the game in how it will looks, we actually need camera in scene. We will always need camera in scene, or otherwise nothing will be rendered. If you just add camera to the scene, it will be added where the 3D cursor is, and it will be already rotated uh, in the way you are looked in the scene. So with just Alt R you can clear the rotation. Same thing is for Alt S or Alt G. It will just clear location and clear scale. And we will look at it like keep the camera up in the Z-axis, like here. I'm now in orthographic view and from the side, so I am sure I am still the location of the camera is on the y-axis, or I am not changing the x-axis of the camera, and rotate it kind of to the center of the scene. And here I am going to camera view with the 0, put it as whole view, so this is what the camera see. And just few things in the control or properties panel, we don't need grease pencil, and in view, not in view, in display we will display only render, and we want textured view. And now this is how our game looks like. We can tweak little bit the color of background. And for our game, for any game you will do, it's necessary to know already where you are going, not just run around trying, or maybe cube, or maybe sphere. No, before you make the game, actually take pen and paper, draw some concepts, write something down. Believe me, you will never remember everything that you want to make, and just go for a pure goal, which is already defined, even if it's defined by you, or you will work with someone or for somebody. So you have to go not just thinking, oh, what should I do now? You should already know. And I know that I want plane which will be 10 by 10 units, and some walls around, and player will be just sphere or ball, exactly with 1 meter of diameter. So I want exact units, so I don't want really use just Blender units. I can set it in the scene, where in units I will use metrics, not just none. It's default for Blender. There are some units, and metrics, I know its length is 35 millimeters, or the location is something meters. So I am pretty happy with it. And other things, everything keep organized. So every time you create something like this camera, change its name so you know what it is. You can do it in the object properties panel, just right here the name, or in the outliner, which I found kind of quicker if you are somewhere else, with just control and left clicked on the name and change it to camera main. Oh, camera main. And I can create our plane. So just everything that will be in the game engine should be some mesh object. It doesn't matter which one, but it has to be mesh object. A Blender game engine can work with curves, but can't really render them properly. So don't use surfaces and curves for, or metaballs. I'm not sure, but I'm sure they don't work as you would expect in the Blender game engine. So just use mesh plane, and you can change the dimensions of the plane. It will place it where the 3D cursor is. It don't necessarily have to be in the center of the scene, so it could place it somewhere here. So we want restore or reset or the transformation to place it exactly into the center, and change the scale to some exact dimensions. So we can go to object properties, or if you remember the shortcut Alt G will restore it, but if you don't want to remember the shortcut for some reason, or you just want to know where it's properly done, you in the object properties you can see the transform label, transform tab, and you can see here location, rotation and scale of this object. And if you hover on any of these columns, you can hit backspace and it will reset location to 0, 0, 0, rotation to 0 and scale to 1. If I scale it in x-axis and hit backspace, it will reset it all to 1. And remember, take some notes somewhere. When you working in Blender game engine, you always want the scale in 1, 1 and 1. If you are certain that you want some other scale and you know what you are doing, you are pretty advanced user and you already done some testing with it, go for it. This is why it's here, that you can change it. But for physics calculation, you always want the scale to 1. So how the hell we should change the dimensions? It's kind of workaround in the properties panel under N, or you should have these pluses here. You have dimensions right here. So I want 10 by 10, so in X 10 by 10. I am happy with what I see, but the physics engine isn't happy what it has calculate, because scale is 5, 5, 1. So what to do is Ctrl A and apply the location, rotation, scale, whatever we want. Always just scale, because the rotation of objects we usually want the rotated object, but scaling always 1. Okay, we have our plane, which is visible from both sides, but it's visible only in your view, not in the engine. And if you want to be certain what is visible and what not in the engine, activate in shading here the backface culling, because backface culling is how the Blender game engine works, and pretty much any engine. This plane is just one face, so it can face only one direction, and this faces up, and from bottom it's invisible. The backface culling is good to control yourself. If, for example, I scale it on z-axis to some negative number, I changed the normal, so the normal is from the bottom, and now the engine wouldn't work as I want. So I will just Ctrl Z it back So I see it's facing the right direction. And this is not plane, this is our ground, so we should name it. Always name your objects. And we will need some walls, but we can keep it for later because walls are only for physics and it will be in other tutorials. So we will just make our sphere as player. You can use UV sphere or icosphere. I like more the polysphere because of topology and its right amount of faces. If you don't have here polysphere, I believe it's an add-on for add more objects or custom objects or whatever. If you don't have it, you can create one for yourself just with cube and two modifiers. So add the modifier subsurf with level of 3 or 2 or whatever resolution you want. I want 3. And the cast modifier with factor 1 and radius 1. If I apply both these modifiers, I have polysphere. So quads only, perfect sphere, and always go for smooth shading, because it actually, if you apply some normal maps or later some textures or anything, it will be smooth shaded. So you want it even in your viewport. You can go to the properties panel on the left side, so with T, and find smooth, or if you are using pie menus, sorry, just go to whatever is shortcut for shade, and you don't have only solid or wireframe, you have shade smooth, and it's smooth out your object. And this is sphere with radius of 1, but we want diameter of 1. So we will scale it with 0.5, so exactly half, and move it along z-axis again by 0.5. So it lands perfectly on our ground. And this is again not a sphere or cube, this is our player, so name it. So we have ground, we have player, but if you look to your game view or whatever is this window is, where I turn off the handles, so it's actually what it should be, you can see it's black only, and it's not good. It's because there are no lights, so we add light to our scene. For properly lighting, we actually need materials. It doesn't matter what materials, just some materials, because if we go to the ground and look what material it has, it don't has any material. So add new, for example, some gray material. We don't have to actually change anything, just, well, no, we don't have to change anything. It's only that it's here, but it doesn't change the problem that there are no lights. So we will add two lights, one main light for main lighting and shadows, and one fill light. I will add the same directional light as the sunlight as in the tutorial for Unity, and place it where I want to place it, in the z-axis like 16. Well, if you are familiar with the sunlight, you should know that it's directional light for the whole scene, and it lights every object evenly regardless of its position. So why am I moving it? It's because we want this light to cast shadows, and shadows are actually casted from the light, not just calculated for all the scene. So we want the light as it would actually lighting our sphere. You can see here that it already works, kind of. We will rotate it so uh, the light will be tilted. So in its properties, for example, -50 and 120, it's pretty much same lighting as, again, I will still reference the Unity tutorial. And from the top view, move it that way that the dotted line will disappear in the in the middle of the ground plane. So this way I am certain that the shadow will be casted on the whole plane. And for now we don't have any shadows, so just go to the sun. Again, I forget to rename it. Main light. And here in its setting, we can keep energy, specular, diffuse, what it is, and we activate shadows. It's already start to cast the dynamic shadows, and because this will be very basic game or very easy to computing for the PC, we can go to high definition shadow, I would say. So go for variance, which is soft type of shadows. Change the bias as low as you can, and then play with the size, its resolution of the shadow. And I will use something like 1024 should be enough for nice smooth shadow. If I look here, yes, it looks pretty nice. And to be sure that we don't lose our shadow anywhere, just take your ball and try it to place everywhere on the plane, and you can see shadow is everywhere. We don't lose it anywhere because the light has the first room size, and if we set it to something very low, like 1.2 meters, we actually will lose our shadow. You see, we can go from the first room size of the light and lose the shadow. So keep it what it was, like 10, and it kind of looks small to me, this plane, and I'm right. I made it just half. I want 20 by 20. I have to keep looking for the reference tutorial, sorry for it. Again, I just scale it twice, and with Ctrl A I apply the scale because I want always applied scale. And we want somehow to fill light from the bottom, like the bounced light from the main light will color the bottom of the sphere, so it will divide it from its shadows. And in the Unity tutorial they are using the directional light again, and just change the transformation and strength and so on. But it's not really a good way how to make fill light, this type of fill light. If you have just ground plane and you want simulate the reflected light from this plane, you will use lamp hemisphere, and this hemisphere you rotate the way you expect the reflection of the light. So in this case I will rotate it by 180 degrees, so it will face from the ground up. It's kind of like directional light. It doesn't matter where this light actually is in the scene, but it's fill light, so we will not use the specular light of this. Change the energy to some very low, like 0.1, and change the color to hint the color of the ground. So for example, like very light blue. You can see it already kind of works. For example, if the ground, let's say, would be green, you would want this light to be slight of greenish, and it's like it almost global illumination. Well, of course it's not, but it's the effect that you can achieve. And well, it looks kind of nice, and we just clear the outliner a little bit, because I want to stay under 35 minutes. It's already too long. And to clearing the outliner, same as you are making directories and files in your computer and stack things together, you can make empty objects which has nothing else to do than store these other game objects. So you can add empty, choose the type whatever you desire, like plain axis, it doesn't matter. Name somehow the empty, like lighting, and parent our lighting hemi and mainline. So hemi will be fill light, and parenting can be done just with picking the icon of the fill light with left mouse button and drop it. You can see there right drop to set parent to lighting, so I will drop it. Same for main light, drop to set parent, and it's there. And I will not change the light till the end of the tutorial, so I can hide it from view with this eye. I will not turn off the rendering, because I want this light still render in viewport, as you can see if you turn it off. But you can turn off just the viewport, so it don't go in the way. And well, it's everything for this lesson. I thank you very much for watching. And in the next lesson we will start to make physics for our little ball, and we will start to move him around by the keyboard. So prepare for some Python scripting. Thank you for watching, and till the next time, bye.